Let's start today's tutorial. So let me make sure that my voice is clear. Not hello. Yeah, I think my voice is clear. So let me check. Then let me check my sound settings. Input. Okay. So I think it's fine. So let's start today's tutorial. So first of all, let me share my screen. How to see a screen? Okay, let's start today's tutorial that I want to solve the assignment that had been given at week 11 previous year. So first, question 1. Question 1 is following. Let x1, x2, x3, x4 and x5 are IID random variables follows a binomial 1p. To test the hypothesis, my null hypothesis is p is 3 by 4 and alternative hypothesis is p is 4 by 5. Now consider the test. My test is reject H0 if summation 1 to 5 x are greater than 3. Now we have to find the size. Find the size and test size and power of this test. If size and power of this test is alpha beta, then find alpha plus beta. So let's find it. So what does this alpha means? Alpha means it is the type 1 error. That means probability that H0 is true, that hypothesis is true, but I am rejecting the null hypothesis. Null hypothesis is true. In this condition, I reject the hypothesis. So reject the hypothesis if summation of xi5 greater than 3. So that is xi greater than 3. So if this condition is satisfied, then we will reject the null hypothesis. So what is the probability of that? And we know that the summation of n binomial distribution, suppose x, so summation of n binomial distribution will follow a binomial with parameter n p. So here n is 5. So let's y is the variable, summation I equal to 1 to 5 xi, then it will follow binomial 5p. So that means now what is the probability that p0, this new variable y, greater than 3? So let's calculate it. Y greater than 3. Let's calculate y. What is the greater than 3? If probability is 3 by 4. So greater than 3 means it will be either 4 or 5. 4 or 5, only these two numbers which is greater than 3. So we have to find the probability of y equal to 4 and y equal to 5. This means p equal to 3 by 4 at y equal to 4 plus p equal to p 3 by 4, y equal to 5. So according to the binomial distribution, this is 5c4 p to the power, so p is 3 by 4, p is 3 by 4 to the power 4, or 1 minus 3 by 4 is 1 by 4, so 1 by 4 to the power 5 minus 4, so this is 1, plus 5c5 3 by 4 5 and 1 by 4 to the power 0. So this is, if you calculate it, you will get that the summation is 81 by 128, which is 0.6328. So alpha is this. Now calculate beta. Beta, if the beta is the power, then 1 minus beta is the probability of second type of error. Probability of type 2 error. Type 2 error. That means accepting type 2 error, that means accepting the hypothesis, null hypothesis, when it is wrong. That means wrong means that is alternative hypothesis true. So what the beta will here, then beta will be 1 minus type 2 error. So this means, this probability means 1 minus probability of accepting when H1 is true. So 1 minus this means that probability of rejecting when H1 is true. So that means probability under the H1, that is p equal to 4 by 5, that my random variable y greater than 3. So one can calculate this. Yeah, one can calculate this. So this will be probability that 4 and 5, so that will be 5c4, here 4 by 5 to the power 4, and 4 by 1 minus 4 by 5 is basically 1 by 5, so this will be 1 by 5 to the power 5 minus 4, basically 1, and 5c 5 4 by 5 to the power 5, and 1 by 5 to 0. So this will be 0.73728. Now if you add alpha plus beta, you will get a number 1.370. So that's it. So that's the answer. Now let's go to the question number 2. In the question number 2, it is said that x1, x2, x3 be a random variable IID. The probability distribution is fx equal to lambda e to the power minus lambda x when x greater than 0 and 0 elsewhere. Now here hypothesis states, the null hypothesis is lambda equal to half. So null hypothesis, basically null hypothesis is lambda, and alternative hypothesis is lambda equal to 1/4, and we have to find the most powerful, test. Most powerful means when, while keeping alpha constant, that means while keeping the type 1 error constant, we have to find the most powerful, that means beta is largest, and if there exists such test, that is called the most powerful test. So from the NP theorem, the NP lemma, Pierre, Lemon, Neyman Pearson lemma, we can calculate it. So let's calculate. So for that we have to we have to know that the joint distribution of this variable. So suppose the joint distribution will be joint of 3 will be, since they are independently distributed, that will be that is I equal to 1 to 3 lambda e to the power minus lambda xi. So this is lambda cube to the power minus lambda summation of I xi, sorry, lambda summation xi. Okay, then for for h0, what will be the f0? That will be, since h0 is lambda equal to half, so half q e to the power minus half summation of xi, and under h1 the distribution, joint distribution will be, this is 1/4, so 1/4 q e to the minus 1/4. So this, now from the Neyman Pearson lemma, Neyman fundamental lemma, okay, the most powerful test, the most powerful test for a given alpha will be reject h0 if f1 by f0 is greater than k. So let's put all the things together. So it will become that f1 means 1/4 cube e to the power minus 1/4 summation of xi, and 1/2 its cube e to the power minus 1/4 summation of xi greater than k. Now these things will be constant, so I can adjust these constant so that these will become, one is half, this is half, so it will be minus 1/4 plus half summation of xi greater than k. So this is e to the power half, so this will be plus 1/4 xi. So suppose this is k prime. Now this is k double prime. Again we'll get a such that xi will be greater than some k naught. Now we know since the alpha is known, so that means what is the probability that we will reject this test when h0 is true. So under h0 we will reject, that means xi should be greater than some unknown constant, and that will be alpha. So since that is that, now we, so here the that means if this condition satisfied, then we will find a k0 value of k0 for which these give the maximum, the most powerful test. So that is that. Now let's go towards the second question number 3, that is x1, x2, xn follows their IID, and each of everyone follows a normal distribution with mean mu and standard deviation 1. And here the null hypothesis is mu is 0, and alternative hypothesis is mu is 2. Now assume the critical region, assume critical region is given by x bar is 1 by n summation of I equal to 1 to n xi if its sample mean greater than half. That is the critical region. This means this is critical region, means this is the test for which, if it is true, this is the test. It says that if it is true, if the above condition is true, we reject the null hypothesis. So then we have to find the minimum sample size required, so that the probability of type 1 error is less than 0.05. So we have to find what is the probability of type 1 error. So type 1 error means reject the null hypothesis when it is true. So that means that P under H0 when it is true, that means when x bar is greater than half. So this is alpha. And we know that this x bar will follow, a distribution that is mu and 1 by n. So this means, and we have to find a condition for which this is this. So that means this will be pH0, x bar greater than half is less than 0.05. So let's do one thing. So pH0 x bar minus mu will greater than half minus mu less than equal to 0.05 pH0. So that x bar minus mu by sigma is 1 by n. So that means 1 by n half minus mu is less than equal to 0.05. So 1 by root n. So this is H0 root n x bar minus mu greater than root n half minus mu 0.05. Now under the H0, what is the value of mu? Mu is 0. So that means p is 0, that is this variable is z greater than, this is root n by 2, since mu is 0, is less than 0.05. So this means root n by 2 greater than equal to this. We know that, let's see it graphically. Okay. So suppose this is z, okay, this is fz, this is phi z, this is z, and what is the probability that z greater than, so this region is alpha. Now not alpha, this, suppose that this region is the, suppose the probability of this region is alpha. Now if I have to find such alpha where this alpha is lesser than a predetermined value. Suppose this is the point 0.05, then if I have to find another alpha which is less than or equal to this, that means that region should be inside this, that means here, because after this region will be, suppose this is alpha prime and this whole region is alpha, the probability that any random variable will remain inside this curve, inside this black curve, is, if it is alpha and blue curve is alpha prime, we can see pictorially that alpha prime always be lesser than alpha, and a z has to be then, since it is in the right side, that means here if it is suppose a random variable z and here is z prime, then z prime actually has to be always greater than z. So that means root n by 2 has to be greater than the z alpha point. So what is the z alpha? That is, alpha means here z alpha point, that is alpha here 0.05. so this will be become, this will be root n by 2 should be greater than or equal to 1.64. This is n should be greater than equal to 10.7584. Therefore the minimum sample size for which these things is true, that that alpha is the type 1 error is less than 0.05 is 11. So that is the answer. Let's move toward the next question, that is question number 4. It is a coin is tossed 4 times and p is the probability of getting head in each trial let S be the number of heads obtained then it is decided that the decided to test the hypothesis, that is null hypothesis. P is half, that means unbiased, against is the against the alternative hypothesis P not equal to half. Using the test function test function phi is 1, that is reject the null hypothesis if S with probability 1 if S is 0 or S is 4, and accept the reject the null hypothesis with probability P0 if S is 1 or S is 3, and reject the null hypothesis with probability 0, that means accept the null hypothesis, that is if S is 2. That is saying the test is such that if and only if we will accept the null hypothesis when only 2 heads out of 4 outcomes is there. So let's see then what is the, suppose the type, now question is suppose the type 1 error of the test is 0.25, find the value of P0 if the type 1 error is 0.25. and let's see the answer of the question. So first let's calculate its what is the type 1 error, that is alpha, that probability of rejecting the hypothesis when it is true. So that means probability of probability of okay, so that will be the probability of when true, that means when that means the expectation of this function. Since you see y expectation, no, let's calculate it. So when we will reject, when the probability is 0 if a is equal to, reject with probability 1 is equal to 0 or is equal to 4, and we will reject it with probability p0 when the probability of when the outcome is equal to 1 or is equal to 3. So that's it. Now we know that the S is the number of heads obtained. Now if we assume that head is corresponding to random number 1 and tail is corresponding to random number 0, then S will be the summation of xi, and summation of xi will again follow, suppose I equal to 1 to 4, so it will follow again a binomial distribution with 4p. So what is the probability of outcome is equal to 0? So let's calculate under the binomial distribution, that is 4p, so that will be 4c 0 half to the power 0, that is since under the hypothesis null hypothesis the value of p is half to the power 4 plus 4c 4 up to the power 4 up to the power 0 plus p0 4c 1 up to the power 1 and up to the power 3 plus p0 4c 3 up to the power 3 up to the power 1. So this is this is 4c, this is 1 1, so this is half to the power 4 into 2 plus p0 into this will be 4 by 16, this will be 4, since 4c1 is 4, 4c3 is also 4, so 16, so this will be 1 by 8 plus p0 by 2, and we know that this alpha is 0.25, so then the p0 will be p0 by 2 will be 0.25 minus 1 by 8, so this will be p0, this is 2 into 0.25 minus 1 by 8, so this is 0.5 minus 1 by 4, so this will be again 1 by 4. So my test, my test is if when A's outcome is 1 or 3, if I reject the null hypothesis with probability 1 by 4, then the the probability of occurring type 1 error is 0.25. So that is the solution for the question number 4. Now let's see question number 5. In question number 5, the question is, let x be a single observation drawn from uniform distribution 0, theta, test the null hypothesis, that is theta is 1 against alternative hypothesis theta is 2. Consider the procedure that rejects h if x greater than 0.8. Now if the probability type 1 and type 2 errors are alpha and beta respectively, then which one of the following is correct? So the options are is that A is beta equal to 3 alpha, B beta equal to 2 alpha, C beta equal to 4 alpha, D beta equal to 5 alpha. So we have to basically find what is the relation between beta and alpha. That means we have to find what is the value alpha and what is the beta. What is the probability of type 1 error and what is the probability of type 2 error. So probability of type 1 error is, under the condition we have to reject the null hypothesis. And what is the null hypothesis? H0 if x0 greater than 0.8, then we will reject the hypothesis that theta equal to 1, and that is x is greater than 0.8. So what is the probability that under the H0 we will get this? So this is, since x follows a uniform distribution between 0 to 1, then it will be 0.8. Oh sorry, it will be not 0.8. What is the x greater than 0.2? That means this is equivalent to probability of a under H0, that is x less than equal to 0.2. So that's it. If it is so, then this probability will become 0.2. So alpha equal to 0.2. Now find beta. What is the meaning of beta here? Beta means the type 2 error, that is probability of accepting H0 when it is false. So that is false means the alternative hypothesis is true. So that under alternative hypothesis, what is the probability of accepting H0? So this is accepting H0 means this is 1 minus probability under H1, that is rejecting the H0. So this will be 1 minus under H1, rejecting means x greater than 0.8, and under H1 this is a uniform distribution 0 to 2, so this will be 1 minus. So what is the probability that x will greater than this? Means again 1 minus probability of H1 less than equal to 0.2. So this is the probability of H1 x less than 0.2. So that is 0 to 2 means 0 minus 0.2 minus 0. So this will be 0.2 minus 0 by 2 minus 0. So this is 0.2 by 2 is beta. So 0.2 is 2 beta, and we know that what is the value of alpha, that is 0.2. So this means 2 beta equal to alpha. So that is the true answer. So true answer is B. 2 beta is 2 alpha. Did I something wrong here? This should be 0.2. I think I did some mistake. Under the theta 2, what will be the probability? That will be okay. I did one thing wrong, that I assume this is okay. Sorry, this is my false. This is not true. So this is not true. This is not true. So so this is not true. So 1 minus probability that under theta equal to 2, x greater than 0.8. That means under theta equal to 2, this will be minus 2 minus 0.8 by 2 minus 0. This is 1 minus 2 minus 0.8. This will be 0.4. So this is 0.4. So this is beta, and alpha is 0.2. So beta by alpha is 0.4 by 0.2. So this is beta equal to 2 alpha. So that is answer B is true. That's all. Let's move toward the question number 6. Question number 6. Consider the following probability density function. Density function that is f0 x is 2x if 0 less than x less than 1, and it is 0 elsewhere, and f1x is uniform distribution 1 and 0 if 0x less than 1 elsewhere. Now let x be a random variable having PDF f belongs to f0 f1. Consider testing h0 equal to fx equal to 0. That is, null hypothesis is that probability distribution is f0x against fx equal to f1x. So at alpha, at probability of type 1 error is 0.05, level of significance for which of the following, and we have to find the most powerful test. So here we can use the Neyman-Pearson fundamental lemma. So the most powerful test is given by reject h0 if f1x by f x is greater than k, where k is determined by probability that under H0 the this is since this is states that if it is true we'll reject the hypothesis, so this is equal to alpha, so this will be the type 1 error. So let's see what is the f1 by f1x by f1x by f0x. So that is f1x is 1 and f0x 2x, so this will be 1 by 2x for the region 0 to 1. So this is less than k, which means okay, this is greater than k, this means x is 2x is less than some other constant, which is x means less than some other constant. Now we know that probability that x under h0 x is k0 is alpha, so let's find the probability. So this is 0 to k0 x dx, right? 2x dx, sorry, this is 2x dx, that is equal to alpha. So that means k0 square is equal to alpha means 0.05, that is 1 by 5 by 100, 1 by 20, 1 by 20. So k0 is 1 by root over 20, so this is basically 2 root 5. k0 is 2 root 5. Then the question is we have to find the most powerful test, or another thing is most powerful test is that when x is greater than, sorry, x is less than, right, x is less than k0, x is less than this number, that is 1 by 2 root 5. If it is true, then reject the null hypothesis. So another question is that if we observe that this is for which of the following observe values of random observation x, the most powerful test would be inject H0. The options are following: A, x is 0.3, B, x is 0.4, C, x is 0.2, T x is 0.5. Now you have to find that among these four, which one is lesser than 1 by 2 root 5, and it appears that the point 2 is less than 1 by 2 root 5. So when x, the outcome is x equal to 0.2, we'll reject the null hypothesis. So that is the answer of question 6. Now let's go toward the question number 7. That's question 7. Question 7 is following. Is x 0, 1, 2, 0, 1, 2, 3, 4, f0x and f1x. So now f0x, if x equal to 0, f0x is 0.5, this is 0.1, this is again 0.1, 3 is 0.1, everything is 0.1. Now here it is 0.1, this is 0.1, this again 0.1, this is 0.2, this is 0.2, this is 0.3. 1, 2, 3, 4, 5, 1, 2, 3 and 7. Okay, now question is, consider the problem of testing of null Ashish, that is h0 is x is f0 against h1, x is f1 based on a single observation. X. So if alpha and beta respectively denote the size and power of the test, with critical region x belongs to, that is real number, and x is greater than 2, and then 10 alpha plus beta is equal to what? So let's find that. Now Here, if we have to find the what is the probability of size and power. Size means simply the probability of type 1 error. So the probability of type 1 error, type 1 error is alpha equal to, under the hypothesis, this is the critical region, and under this thing will reject the null hypothesis. So what is the probability that x is greater than 2? So what is, let's check. X is greater than 2 means it is either 3, 4 or 5. So what will be the probability? 0.1 plus 0.1 plus 0.1. So that is 0.1 plus 0.1 plus 0.1, that is 0.3. Now the power is the probability of accepting the null hypothesis. This is when it is false. Sorry, null hypothesis, this is rejecting. Sorry, this is power means probability of rejecting, not accepting. This is rejecting. So that means beta will be probability under H1 that x is in the critical region. So under the 2, what is the probability that it will greater than 2, that is 3, 4 or 5, that is 0.2, 0.2 plus 0.3. So this is 0.2 plus 0.2 plus 0.3, this is 0.7. So then 10 alpha plus beta will be 10 into 0.3 plus 0.7, so that is 10. So that is the answer. Let's go towards the question number 8. This is question number 8. A manufacturer is interested in the output voltage of a power supply used in a PC. Output voltage is assumed to be normally distributed with standard deviation 2 volt, and the manufacturer manufacturer wishes manufacturer wishes to test H0 is mu is 5 volts against H1, that is mu is 8 volts. A random sample of size 8 is drawn, and it is observed that mm, sample mean is 6 based on the sample which one of the following is true. A, the most powerful test rejects H0 at level 0.05 P, the most powerful test rejects H0 at level 0.1 C, the most powerful test does not exist, and D is the most powerful test rejects H0 at level 0.025. So let's first calculate what is the most powerful test in general when the standard deviation is same and known, and since both are simple test, so from Neyman-Pearson lemma we can get what is the most powerful test. So let's calculate that first. there are sample size. Oh. Let's calculate what will be the joint distribution under the H0, that is x bar, that will be I equal to 1 to n 1 by root 2 pi sigma to the sigma e to the power minus 1 by 2 sigma square x I minus mu square. So this will be 1 by root 2 pi sigma to the power n e to the power minus 1 by 2 sigma square sigma xi minus mu square. Similarly, so this is mu 0 square. Now let f1 x bar, under the hypothesis that its mean is mu1 and standard deviation again sigma, it will simply become 1 by 2 pi sigma to the power n to the power minus 1 by mu square xi minus mu1 square. So according to the Neyman-Pearson, so from the Neyman-Pearson law, not Neyman, from the Neyman-Pearson fundamental lemma, we know that if f1 by f0 exit a certain level, will, if it is true, then we reject h0. So let what the value is, value will be e to the power minus 1 by 2 sigma square summation of I xi square minus 2 xi mu plus mu square mu 0 square minus x square plus 2 xi mu 1 minus mu 1 square. It is greater than k. So this is xi cancelled. So this will be to the power minus 1 by 2 sigma square mu 0 square minus mu 1 square 2 to the power minus 2 sigma square mu 0 square minus mu 1 square summation xi greater than k. So from here, and if that mu1 is greater than mu0, then this will become, since this is a constant, so we can adjust this constant in this side and we'll again get another constant. So this means e to the power, since this is true, we can write it here, here mu1 square minus mu0 square greater than k into xi. So from, since this is a positive part, so we can write it in this way, that summation of xi is greater than some predefined constant k0. Now let's do it. So okay, so if it is true under the hypothesis h0, then we will reject the null hypothesis. So that is the error, type 1 error. Summation of xi greater than k0, you can write it p of h0 summation of xi minus mu0 by sigma 10, this will greater than some another constant k0. So that means this is a standard normal, since summation of xi will follow a normal distribution with mu 0 and sigma by n, sigma square by n. So this is a standard normal, okay, this is a standard normal random variable, so we can write it p of a0, this is z greater than some k0, so this is alpha. That means this k0 is the k0 is the alpha percent point of this distribution. So this is k alpha, z alpha. This is k0 is z alpha. So that means k0 is z alpha. K0 is z alpha. Now the most powerful test rejects H0. We know that sum of xi is 6 and n is 8. So then let's check the option 1, that is the most powerful test rejects H0 at level 0.05. So let's put all things together. So that will be when summation of xi minus mu 0 by sigma is 2 root n by 2 is greater than z alpha point. So this is sigma, and here also know that mu 0 is 5, sigma is 2, n is 8. So let's put all the things together. So n is root 8, this is 6, minus mu 0 is 5 by 2 is greater than z alpha. So this is, now let's first check. So is it this will be 2 root 2 by 2, so root 2 means 1.414 z alpha. Now if alpha is 0.05, we know that z alpha means 0.05, okay, 0.1 is the point 0.1, this is 1.28, so obviously 1.414 is greater than 1.28. So under the point 1 significance level we can reject this. Let's check when GA equal to 0.05, that is 1.64, and 1.414 is less than 1.64. So under this significance level, level 0.05, we cannot reject the null hypothesis. And see, the most powerful exists, and the most powerful test rejects. So z equal to 0.025, z equal to 0.025 is 1.96, and 1.414 is less than 1.96. So So you cannot reject the H0 at level alpha equal to 0.05. So you can reject the H0 under at level 0.1. So the option B is correct. Option B is correct. That the most powerful test rejects H0 at level 0.1. This is correct. So this is the question 8. Now move to the question 9. That let x1, x2, xn be a random sample drawn from mu sigma square distribution where mu is known, the most powerful test at level alpha for testing H0 is sigma square equal to sigma 0 square against alternative hypothesis is sigma square equal to sigma 1 square, where sigma 1 square is less than sigma 0 square, is given by a reject H0 if 1 by sigma 0 square sum xi minus mu h square greater than equal to chi square n minus 1 alpha. B reject H0 if 1 by sigma 0 square x square minus x minus mu h square less than equal to chi square n minus 1 comma 1 minus alpha. C reject H0 if 1 by sigma 0 square summation of xi minus mu square greater than chi square n alpha, and D is reject H0 if 1 by sigma 0 square is xi minus mu square less than chi square n 1 minus alpha. That we have to check which is the most powerful test. Okay, so we again use, since both hypotheses are simple hypothesis, so we'll use Neyman Pearson test here. So let's do it. So for that we have to know the joint distribution, and since these are IID random variables, so only the multiplications are the joint distribution. So let's write the joint distribution for H0. That will be 1 by root 2 pi sigma 0 square e to the power minus 1 by 2 sigma 0 square summation of xi minus mu h square, and under the h1 this is 1 by root 2 pi sigma 1 to the power minus 1 by 2 sigma 1 square sum over x minus mu square. So according to the NP Neyman Pearson fundamental lemma, we will reject the hypothesis H1 if F1 by F0 is greater than K. So okay, so to the power n, this will give e to the power minus 1 by 2 sigma 1 square summation of xi minus mu square plus 1 by 2 sigma 2 square summation of xi minus mu square will greater than another some constant, so k prime to the power summation xi minus mu square by 2 1 by sigma 2 square minus 1 by sigma square greater than k prime. Now you see here sigma 1 square is greater than sigma 0, so this is sigma 0. So here sigma 1 square is less than sigma 0 square. Sigma 0 square, that means 1 by sigma 1 square is greater than 1 by sigma 0 square. So this means sigma 0 square minus sigma 1 square is less than 0. So this is negative. So that means if summation of xi minus mu its square is less than some constant, then we will reject the null hypothesis. Now suppose and we know that the probability that this xi minus mu its square less than k0 is alpha. That is the size of the test. Now we know that summation of xi minus mu its square by, okay, let's do it in this way. Summation of xi minus mu square the sample mean is S square is by n minus 1, and we know that the S square by sigma square S square by sigma square by n minus 1 follows a chi-square n minus 1 distribution. So this is basically nothing but summation of xi minus mu its square by sigma square will follow a chi-square. a chi-square n minus 1 distribution. So this means if you under the hypothesis H0, so if we do this, this will be P0. Now if we modify this is a little bit by divide both sides by sigma square, we'll get summation of xi minus mu square by sigma 0 square less than some other constant. Suppose that constant is c is alpha. We know that this follows the chi-square distribution, and this follows a chi-square distribution, chi-square n minus 1 distribution. Suppose this is the chi-square distribution, and if this region is alpha, the probability of this region is alpha, this region will be 1 minus alpha. So this point is C is chi-square n minus 1 minus alpha. Right, let's see. So I think this is not this is, I think this is not n minus 1, this is in, this is in, this is in, this is 1 minus alpha point. So that means if 1 by sigma 0 square summation of xi minus mu its square if less than equal to chi-square n 1 minus alpha, then you will reject the null hypothesis. That's it. Now this is the question, the last question, that is question number 10. Move toward the question number 10. Question number 10. Let x1, x2, xn be a random sample drawn from a continuous distribution with probability density function fx is 1 by lambda to the minus x by lambda, x greater than 0 and it is 0 elsewhere. Consider the problem of testing hypothesis age, that is lambda equal to 1, against hypothesis, that is lambda equal to 2, based on the random sample x1, x2, xn, then which of the following is false. So we have to basically check the most powerful test. So let's do it. Clearly both null and alternative hypothesis are simple. The joint distribution function of x1, x2, xn is f of x bar is pi I equal to 1 to n 1 by lambda e to the power minus 1 by lambda xi. So this is 1 by lambda to the power n e to the power minus 1 by lambda sum of xi, I equal to 1 to n. Therefore for lambda equal to 1, the joint distribution of x1, x2, xn is f0 x bar is e to the power minus summation of xi, and for lambda equal to 2, the joint distribution of x1, x2, xn is f1 x is up to the power n e to the power minus half summation xi. Therefore, by the minimum Pearson fundamental lemma LEMMA fundamental lemma, the most powerful test at the level alpha exists for each alpha, and it is given by reject H0 if f1 by f0 is greater than k, and k is determined from the size. Now, where k is determined from the size condition, P under H0 reject the null hypothesis, that is alpha. Simplifying this equation is 1 we get reject H0 if 2 summation of I equal to 1 to n xi greater than c, where x is determined by where c is determined from this sample equation, that is probability of H0 2 of I equal to 1 to n xi greater than c is alpha. This means c is equal to chi square 2n alpha point. So therefore most powerful test at level alpha is reject H0 if 2 to summation I equal to 1 to n xi greater than chi square to n comma alpha point. Since both h0 and h1 are simple hypotheses, the distribution the most powerful test statistic is completely determined again by the Neyman Pearson fundamental mental lemma, the most powerful test for the given testing of hypothesis problem exist for any level of significance alpha between 0 comma 1. Therefore the option D is true. That's it. So that is the thing I want to solve today. So that's it. So now I'm gonna leave this meeting.